Hello and welcome to the Boolean Logic introductions. Boolean Logic helps us to evaluate whether something is true or false. We need to have this for our if statement and our Boolean statement, for example, when we're stopping loops. In this first statement, we're saying that if I is over 0 and my string, so whatever I type, equals yes, then the statement is true. And while the user has not entered the word quit, the statement is true and the loop keeps continuing. Here I've written these statements in Java, but we need to have something more generic. So that's why Boolean statements exist. So if we take a look at what we remember from if statements, when the word and is used, that means everything has to be, all conditions have to be met in order to get a positive output. An example of this is, in order for me to jump in the lake, it has to be both sunny and warm. In an OR gate, only one of the outcomes has to be true in order for the condition to be met. So for example, if it is raining or I have no homework, then I will go to the cinema. So it can be one or the other, or both conditions can be true in order for the outcome to be true. A NOT gate is slightly different. What happens is it negates the input. So a 1 becomes a 0 and a 0 becomes a 1. This will make more sense once we start to have a look at truth tables and circuit diagrams. A NAND gate is the opposite of an AND gate. So that means if both inputs are positive, then you get a negative output. However, if you've got both negative inputs or one of the inputs negative, then you get a positive answer. If you have a NOR, then if there's any input, then the output is negative. We know this from the OR gate, that it only has to have one input for it to be positive. However, it's the opposite of the OR, so even if there's one input, everything is negative. And our final one is the exclusive OR. It operates the same as an OR gate, except it must be one or the other. You cannot have two inputs to get a positive output. Okay, let's do an output. So if we have a statement, we can place it into Boolean logic. So if it's sunny and warm, I can swim in the lake will be A and B. So the dot means and. So if it's A, then I put a dot, and it's not raining, so I put B, and to show that it's not, I put a line over it. The next one is if it's raining and I have no homework, so I put B, A, and B with a line over it. Try not to be confused because a plus means or rather than a plus means and. So let's now do an example with three inputs, A, B, and C. Here we have an and statement as well as an or statement and a negative statement. So if it is raining and I have no homework, or there's something I really want to see, now, this is easy because A is the first variable and we know it's A and B, so I put the dot, and then we know it's B or C, so I put the plus. Don't forget to put the top over the B to show it's negative, and if I put the brackets around it, that shows that these need to be evaluated first, just as in maths.